So this is the last section that we're going to cover. It's 18.6. And 18.6 is called Further Graphing of Quadratic Functions. Basically, it just tells you a different way you can graph if your quadratic equation is given to you in a different format. So we'll look at that. So it says, recall a quadratic equation in this form. So this is what we learned in 18.5. We knew our shifts, right? This was left or right, this was up or down, and this was a stretch. Our vertex was just HK. It was from our shifts. Right? So whatever we moved left or right, that was H for our x value of our vertex. Whatever we did up or down, that was K for our vertex. Remember, x-intercepts are where the graph crosses the x-axis, so we're going to set y to 0. And the y-intercept is where the graph crosses the y-axis, so we'll set x equal to 0. So why is this different? What you'll notice is that this quadratic equation is more like the quadratic equations we've seen as far as factoring goes, but it's not in this format where you can tell what the shifts are or anything, all right? So what we do is we complete the square, all right? So this is the one place where completing the square actually has a purpose or a job. I would never use completing the square to actually solve an equation. I would factor or use a quadratic formula. But by completing the square, we'll have it in that format, and we'll be able to know our shifts, okay? The only difference between these problems and the ones we did in 18.1 is that f of x stays f of x, it's not 0. So f of x kind of just hangs out. He's like that creepster that's just kind of watching you do stuff, okay? And he's there hanging out, and he's part of it, okay? So what we want is we always want our x's together, right? So what do we need to do with this negative 3? We don't want him there. What do we need to do to him? Add him to the other side. And when we add him, he's going to be with f of x, okay? So f of x will be there, plus 3 equals x squared minus 2x. Okay? And that's what's different. Before that was just a 0, so when you added 3 over, it was just 3. All right? My next move is I want to start completing the square, so I know I'm going to eventually add stuff to both sides. So this will just be f of x plus 3 plus blank equals x squared minus 2x plus blank. And he's kind of flipped, too. That's what's kind of weird with this, because you're used to having like the x squared plus x on the left and the 0 on the right. But that's okay. We can let it hang out. So just kind of let this hang out, and we focus on this side. What was step number 1 of completing the square? What do we need to do? What do we need to do to b? What do we need to do to our negative 2? Divide by 2. So we're going to divide negative 2 by 2, and what do we get? Negative 1. Is that what I add to both lines?
No,
I have to square it first.
positive.
Yep. So we'll have positive 1, positive 1. Is that okay so far? All right. On the left, we can do the math. Do we know what f of x is? No. So he stays f of x. But what's 3 plus 1?
4.
4. So this will be f of x plus 4 equals, and on the right, remember, we have a factor. What are factors of 1 that add up to negative 2? Negative 1, negative 1. But remember, that's just that shortcut. This will just factor to x minus 1 squared. Remember, we made a perfect square trinomial. That's the whole point of completing the square. We made a perfect square trinomial. All right, guys, we're almost there. We almost have it what we want it to look like, right? What we want is we ultimately want it to look like this. F of x equals, so we want to get f of x by itself, so what do we need to do with this 4? Subtract them over, and let's just subtract them to the back, all right? So what do we have? We have f of x equals x minus 1 squared minus 4. F of x equals x minus 1, the quantity squared, minus 4. And what's crazy is if you actually FOIL this out, so if you FOIL x minus 1 times x minus 1, FOIL it out, gather like terms, and subtract minus 4, you'll get the exact same equation. So we have not changed the value of this equation, we've just changed the format, so we now know what our shifts are, right? What does this minus 1 on the inside do? What direction are we shifting?
Down.
Nope. Inside's always left or right. To the right 1. The outside's up or down. So what's this minus 4 going to make us do? Go down. All right? So now we can graph him. So your vertex, like I said, kind of hover over 0, 0, but now we're going to go to the right 1 and then down 4. 1, 2, 3, 4, and put your vertex right there. To the right 1 and down 4. Alright, your next move is to graph your other ordered pairs. But notice your the value of A is just a positive 1, meaning we're going to open up and it's nothing stretched or widened, and we're just going to go over 1, up 1 from the vertex, over 2, up 4 from the vertex. So over 1, up 1 from the vertex, over 2, up 1, 2, 3, 4. All right. So since he's kind of your standard, and you can even, we'll see it way up here, your A term is just a 1, right? So he's just going to open up, and he's just going to be your normal over 1, up 1, over 2, up 4 values. All right. So what did this ask us to do? It asked us to find the vertex. So the vertex we should know. If we went to the right 1, we're at positive 1. If we went to the down 4, we're at negative 4. So that's the vertex. But then it also asks us to find any intercepts. This one happens to be perfectly where you can see it on your graph, but that's not always going to be the case. So how do we find them algebraically? Well, in order to find the x-intercepts, that means where do we cross the x-axis? That means make y equal 0. Okay? In order to find x-intercepts, that means make y equal 0. What is y when you look at your function? Y is the left-hand side. It's that f of x, okay? So we're going to let f of x equal 0. So this is just 0 equals x squared minus 2x minus 3. And you're going to see everything come into play from this whole semester. How do you solve a quadratic equal to 0? Well, you have multiple ways now. You have the quadratic formula, you have factoring, you have completing the square. On the quiz and on the final, I believe, there will be factorable, okay? So what are factors of negative 3 that add up to negative 2? Well, what's the only way 3 splits up? 1 and 3, right? So we'll have 1 and negative 3. So this is just 0 equals x minus 3, x plus 1. That's just doing the AC method. I know I did it kind of quick, okay? So what are our two x values for our intercepts? Actually, positive 3 and negative 1, because remember we have to set them equal to 0. So in an ordered pair, we'd have 3, 0, and negative 1, 0. Okay? So in order to find x-intercepts, your y must be 0. Your function f of x, that's the y part. So we set f of x equal to 0, and we factored it using the AC method. We got x minus 3, x plus 1. Set each of those equal to 0, you solve for 3 and negative 1. Those are each x values that went with a y value of 0. So your intercept, and if you look at the graph, assuming we graphed okay, it is where it's crossing, right? Mine's spot on. 3, 0, negative 1, 0. But that won't always be perfect where you can just look at your graph and know those. So we need to be able to do it algebraically. We also need to be able to find our y-intercept. Guys, your y-intercept's way easier. Your y-intercept is when your x equals 0. And the reason why he's way easier is because all we're going to do is plug 0 in here, 0 in here, and your y-intercept is always just that constant on the back, okay? So we want to technically find f of 0, right? Meaning this is our x. So 0 squared minus 2 times 0 minus 3. You guys see what I'm doing? I'm just taking my function x squared minus 2x minus 3 and plugging 0 in. So what is technically f of 0? Just that value. That's our y-intercept right there, kind of hanging out. Okay? As an ordered pair, what is he as an ordered pair? What did we put in for x? 0. What came out for y? Negative 3. Look at your graph. Is that where it crosses the y-axis? It sure is, right here at 0, negative 3. So all of it algebraically should match the graph. One thing, because I know Sadie and I were kind of talking about it, in 18.5 when you're graphing, I think the most frustrating part is that you have to do the graph solid, and then you have to graph that line of symmetry, and you have to make sure that's dotted. In 18.6, they ignore the line of symmetry. So you don't need to graph him, and it's hard, like you get excited, but it's hard because you're coming off of 18.5 and you want to put the line of symmetry there, and you don't. So 18.6, we don't talk about the line of symmetry at all right? We just talk about our vertex and then our intercepts. Okay, number 2, guys, exact same idea. Why is he a little bit more nasty, though? What do you notice about our A value? It's not 1, okay? So what we must do is make him 1, so we have to divide everything by 3, including the f of x. Okay? In order to complete the square, your first coefficient must be 1. If it's not, divide everything by that coefficient. Alright, so we're going to have f of x over 3. I'm going to go ahead and subtract my 1/3 over, minus 1/3 plus blank, equals x squared plus x plus blank. Okay? So we don't know what f of x is, so he's going to say f of x over 3. I'm going to go ahead and move my constant over since he's added. I subtracted him over. 1 divided by 3 is just 1/3. 3 divided by 3 is 1. That's the whole reason why we did it. And then 3 divided by 3 is 1. If you want to put a 1x, you can. Alright? I know I want to keep these on the same side and eventually add something to either side, so that's why I would put the plus blanks there. Alright, what's my next move, guys?
Divide the 1/3.
Yes. Well, not the 1/3. Divide your b. What's technically here? A 1. And I'm going to divide that by 2. Okay? What's 1 divided by 2? 1/2. Leave it 1/2. Don't put it in decimal. Leave it as a fraction. Is 1/2 what I add to both sides?
No, but you square
I have to square it still, right? Squaring a fraction is not bad because you just square the top, square the bottom. What's 1 squared? 1. What's 2 squared? 4. So I'm just adding 1/4 to both sides. Alright? So on the left side, you let f of x over 3 hang out, but in your calculator type negative 1/3 plus 1/4, and then hit math frac, okay? So let f of x over 3 hang out, and then tell me what negative 1/3 plus 1/4 is. Negative 1/12. What'd you say? Type this, because you're always going to be able to do the math with the numbers in your calculator. F of x we don't know, so he stays that way, okay? So negative 1/3 plus 1/4 is just negative 1/12, all right? Over here, I know you don't want to factor what are factors of 1/4 to add up to 1, but guess what they are? 1/2 and 1/2. So this factors 2x plus 1/2 the quantity squared. And that's why that shortcut method is so nice, is that you don't have to actually factor with fractions. You just know it's going to be whatever that shortcut is. All right. So what do we still need to do? We still need to get f of x by itself, and he's a little bit different than the first one because not only do we need to move the 1/12 over, but we eventually need to get rid of that 3 that's just kind of hanging out. But let's worry about adding that 1/12 over first. So we have f of x over 3 equals x plus 1/2 squared plus 1/12. Is that okay? All I did was just move that negative 1/12 over by adding him. All right. This is typically not one where we have to do it, but what's the opposite of dividing? Multiplying. So right now this f of x is divided by 3. So what do we need to do? We need to multiply by 3, but we need to multiply both terms by 3. So throw a 3 in front there, but then we're also going to take 1/12 times 3. Okay? Because we want to multiply that whole side by 3 to get rid of the 3. And if we multiply this side by 3, it's just going to cancel out, right? So that's why we're doing it. So we're going to have f of x equals a 3 in front of that quantity, so 3 times x plus 1/2 squared, plus, what's 3 times 1/12? Again, throw that in your calculator and hit math frac, and what do you get? One-fourth, a quarter, yep. And there we did it, okay? So, what is this graph going to look at? Well, let's focus first on our shifts. What's this 3 on the outside going to do? Is that shifting us anywhere? No. What is it doing? It's stretching it, okay? So that's a stretch of 3. What's this plus 1/2 do? It's shifting us which direction? Left. A half. And what's that plus 1/4 doing? Shifting us up. Okay? So the left and the up will be the first things we're going to do. We're going to figure out where our vertex is, and then that stretch is going to tell us, okay, instead of going over 1, up 1, we're going to go over 1, up 3. All right? So this gets kind of hard because we're going to start doing fractions of, squares. So we're going to go to the left 1/2 and then up 1/4. We're just resting right above that x-axis, okay? So it's kind of hard to tell, but halfway is literally halfway, so move over a half. But up 1/4 is basically you're just kind of sitting on top, right? He's not in the middle because it's not a half, it's just up 1/4. So, when we do the over 1, up 1, realize when you go over 1, you'll be in the middle of the next blocks, right? So when we go over 1, we'll be in the middle here of these blocks, and we'll be resting right above them. So when we go up 3, 1, 2, 3, we'll be just resting on top of that, okay? So when we go over 1, this direction, we'll be sitting right here, halfway. I know you can't really see. We'll be sitting right here, halfway in this block, but then we're going to go up 3. So we'll go 1, 2, 3, kind of sit right above that line, y equals 3. And then on this side, when you go over 1, remember that you're going to be sitting halfway there, and then you're going to go up 3. And that's all I'm going to graph because the next move would be go over to up 3 times 4, or 12, and we'll fall off of the graph at that point, okay? So again, trying to make it as U-like as possible. It's hard when it starts getting stretched out that much. It almost starts looking like a V, right? All right, so we still have to answer their questions, okay? So the vertex is all based on your shift, okay? So we shifted to the left, so what's our x value of our vertex? -1/2. And we shifted up, so our y value is 1/4. And even if they don't let you graph first, which I think they should, but even if they don't let you graph first, think about your graph and what it's going to look like for the x-intercepts. Well, the x-intercepts are when y equals 0, but looking at your graph, it's hard to tell. But we're actually sitting above the line y equals 0, so do we ever cross the x-axis? No, so that would just be none, and that's an option, okay? So you'll click none. And then your y-intercept is when your x is 0. But like I said, that's the easy one. That's when you go up to your original, you put 0 in here, 0 in here, and that just leaves you with the 1, right? And if you look at your graph, it looks like you crossed right at 1. So this is f of 0, so we'll have 3 times 0 squared plus 3 times 0 plus 1. But wherever you plug your zeros in, they always cancel out, and that constant in the back is always your y-intercept. So our y-intercept is just 0, 1, which on our graph, you can see we cross that 0, 1. Okay. Intercepts, like those, especially those that are going on to college algebra is just like a big brother version of this class, where instead of just graphing parabolas, you'll graph cubics and rationals and all that stuff. And you'll still need to know intercepts. Where is the x equals 0? Where is the y equals 0? That kind of stuff. All right, so not the most fun. Like, I like this. Like, if you just give it to me like that, I know how to shift it, and I'm done. So what someone figured out, just like they kind of did with the quadratic formula, was why complete the square every time because your function's different? Why not come up with a generic equation that works for every graph? And that's exactly what they did, okay? So this is very key thing here. We can actually, just kind of like I said, someone used the quadratic formula kind of idea where if you complete the square with the generic, your x value of your vertex is always at negative b over 2a. So that's the x value of your vertex. It's always at negative b over 2a. And then your y value is just whatever it is once you plug the x back in, okay? That's the y. It's after you plug it back in. So notice on both of these, 1 and 2, they're the exact same graphs we graphed on the front. So we should get 1 and negative 4 and negative 1/2, 1/4 as our answers by just using this equation, okay? Because once you guys know your vertex, you can look at your A and know whether you're opening up or down and if you're stretching or not, okay? So if you know where your vertex is, that's the key thing, all right? So let's use this formula. In order to find x, guys, x is just negative b over 2a. And you're like, oh great, another formula to remember. No. Realize that's just the quadratic formula without the plus or minus square root, right? It's negative b plus or minus square root, blah, 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 over 2a. So that's just the quadratic formula, just without that plus or minus square root part on the back, okay? So, look at this guy. We have a negative because it's part of our formula, but what's our b? A negative over 2 times a, what's our a?
X squared.
But not x squared, the coefficient in front of x squared. 1. You got it. We're never plugging in variables. We're always plugging in their numbers, right? What's a negative with a negative?
Positive.
A positive 2. What's 2 times 1? 2. What's 2 over 2? 1. All right. And that's what we knew. We knew we're supposed to get 1 as the x value, right? Okay. Once you have an x value, and this is something that I feel like we lose if you took Math 112, is a function is if you know what an x is, you can plug any x in and get the y, right? So if we know the x value for our vertex is 1, we should be able to plug it back up into our function and get the y value. So your y value is just f of 1, meaning plug 1 in there and do the math. 1 squared minus 2 times 1 minus 3. 1 squared minus 2 times 1 minus 3. What do you get?
Negative 4.
Ta-da! And that's what we knew we wanted, right? We wanted 1, negative 4. So our vertex is 1, negative 4. And like I said, knowing that, that should be enough, because we'll go to our vertex, we'll shift to the right 1, go down 4, and then what's our a value? It's a positive 1, meaning we're going to go over 1, up 1, over 2, up 4, right? There's no stretching, and we're going to open up like normal. So as long as you know where your vertex is, you guys can graph your function, and you don't need to do all that magic work that we did on the front. All right, let's look at this one. We're going to do the same thing. What do we know? It's a little bit uglier. We know we want it to be negative 1/2, 1/4, okay? So how do we figure out our x value? It's negative b over 2a. Oops, I'm writing where you can't see it. Negative b over 2a. What's our b in this problem? 3. So we'll have negative 3 over 2 times a, but what is our a? 3. So you have negative 3 over 2 times 3, which is 6. But if you put in your calculator negative 3 over 6 and hit math frac, guess what you get? Negative 1/2. All right. How are we going to find our y value? Well, we'll just plug it into the function. Wherever you see x, put in negative 1/2. So our y value, guys, is just f of negative 1/2. So we'll have 3 times negative 1/2 squared plus 3 times negative 1/2 plus 1. Okay? So all I'm doing is using my equation and plugging in my x that I know I want. So 3 times negative 1/2 squared plus 3 times negative 1/2 plus 1. And if you do that and hit math frac, what do you get? So you get 1/4. It's really important to put parentheses around your negative. So you should get positive 1/4, which means our vertex is negative 1/2, 1/4. Woohoo! And again, once you know that, you know you're shifting to the left a half and going up a quarter. And then this A means we're opening up because it's positive, but it's a stretch of 3. So we go over 1, up 3. All based on that A right there. Are you not getting that?
Yeah, I'm getting negative 2.
Oh, because you never squared that one. So we'll do the second
okay.
entry, and we'll go in and put a square in.
Oh,
If you hit math prep,
yeah.
there you
Okay.
have it. Okay? So, when it comes down to it, do you really need to complete the square? No. If you want to know where the equation looks like in that format, you can complete the square to do it. But if all you really want is the vertex, just remember negative b over 2a, and you'll be able to get your vertex. All right, so the last thing, we're doing okay on time, is word problems. So we've done a lot of word problems where it's like you hit the ground, but a lot of things in real life, you want to know where your maximum or minimum are. Again, if you're going to college algebra, you'll have like revenue functions, like in order to make money, how much do you need to sell in order to make the most money? Well, if you think of a parabola, if we're opening up or down, where's the lowest point? And where's the highest point? Those are always occurring at the vertex. So anytime you're asked about a maximum or minimum value, they're actually asking you just find the vertex, all right? So let's see what it says. It says the f of x or the y value of the vertex is either the minimum or maximum value of your function. If the parabola opens up, you know that your leading coefficient is positive, right? So if you open up, guys, notice that it has a minimum value. So if you open up, you have a minimum, right? Because it's down there, down below. If the parabola opens down, that means the leading coefficient is negative. But if it opens downward, you'll have a maximum. Okay? So I think it's like revenue, profit, cost, all of those are usually quadratic functions where there's a happy medium in there, right? So how do you maximize your revenue? Well, you don't want to sell too many because then that's a lot of time and effort and work you have to pay people. But you don't want to sell too few because then you're not making any money, okay? So it's kind of that happy medium. So let's look at what's going on. It says, a rock is thrown upward from the ground. Its height in feet above ground after t seconds is given by the function f of t equals negative 16t squared plus 20t. So it's like that typical height function that we've seen multiple times. But instead of saying find when the function or the rock hits the ground or the rock is 150 feet in the air, it says find the maximum height of the rock and the number of seconds it took for the rock to reach its maximum height. So this is what gets confusing. Your y value is actually your max or min. Your x value is how many you need to sell or how long. It's how you get your max or min, okay? So what we're going to do is instead of x equals, we're going to have t equals negative b over 2a. Because this means we just need to find the vertex, guys. Okay? If they ask for max or min, you need to think vertex, not quadratic formula. All right. So negative b would be negative 20 over 2 times a, or negative 16. So that's negative 20 over negative 32. And with height functions or word problems, they usually keep it in decimal form. So if you put negative 20 divided by negative 32 in your calculator, you'll get 0.625. But what does that stand for? That stands for t, and t represents time in seconds. So is 0.625 seconds our maximum height? No, that's when we reach our maximum height. So it's when we reach the max height, when max height is reached. Okay? So your x value that you find first is how you're going to get to your max or min. It isn't your actually max or min. Okay? So this is in the air for not even a full second before it hits its maximum height and starts going back down. Okay? What is the maximum height? That's your y value. So we have to find f of 0.625. So kind of like what we did up here with 1 and 2, where we found our x value first, but then we just plugged it back into our function. So this is just negative 16t, but our t is 0.625 squared, plus 20 times t, or 0.625. And I make fun of this problem, and you'll see why in a second. If you plug that in your calculator, plug it exactly how you see it. So negative 16 times 0.625 squared plus 20 times 0.625, you get, I think, is it 6.25? And it's height measured in feet. So So I'm like, did my 2-year-old throw this rock? Like, it didn't go very high, right? So it's not even in the air for a second, and it only reaches a max height of 6.25 feet. So how does it answer this? Your maximum height is actually that value, 6.25 feet. When, though, after 0.625 seconds. Okay? So how you get your maximum is always your x. What the maximum or minimum is always your y.